Hello students, today we are covering lesson 4.2 on solving inequalities using addition or subtraction. Follow along with me in your textbook beginning on page 132. I would like you to pause to write this down. While you're writing it down, I will review it with you. The addition property of inequality says that when you add the same number to each side of an inequality, the inequality statement remains true. In numbers, if you have -4 is less than 3, adding 2 to each side would still keep the inequality true since -2 is less than 5. In terms of algebra, if a number a is less than b, then a plus c is still less than b plus c. And the opposite is also true. If a is greater than b, then a plus c is greater than b plus c. The subtraction property of inequality states that when you subtract the same number from each side of an inequality, the inequality remains true. For example, if you have -2 is less than +2, subtracting 3 to both sides means -5 is still less than -1. So in terms of algebra, if a is less than b, then a minus c is still less than b minus c. Or if you have a is greater than b, a minus c is still greater than b minus c. And these properties are also true if you have less than or equal to and greater than or equal to symbols. So make sure you copy this down and show it in your notes for class tomorrow. Okay, example 1 is solving an inequality using addition. This begins on page 132. We need to solve x plus 5, which is less than -3. Now, solving an inequality is just like solving an equation, except instead of an equal sign, we will have a comparison symbol here, such as less than, greater than, or less than or equal to, greater than or equal to. So to solve, the first thing we need to do is isolate the variable by using inverse operations. The inverse of -5 would be to add 5 to both sides. And because of the addition property of inequality, adding the same number to both sides still keeps the inequality true. So here, those cancel out to 0, and I have x is less than -3 plus 5 makes +2. So now I need to graph the solution. To graph, I have my number line drawn here. X has to be less than 2, but it is not equal to 2. So therefore, I'm going to use an open circle at 2, and I'm going to shade left to show that x is less. And I show my arrow to show that there are more possible values. The solutions are infinite. Okay, let's try on your own. Numbers 1 through 3 on page 132. I want you to solve the inequality by using the inverse operations. And then I want you to graph the solution on a number line. Pause the video to complete these 3 problems. Okay, example 2 is solving an inequality. This time we will be using subtraction. So we have 13 is less than or equal to x plus 14. I need to isolate the variable x. So I will use the inverse operation to get rid of the number next to it. Instead of plus 14, I need to get rid of this so that I can get x alone. So I'm going to do the inverse operation, which would be to subtract 14 to both sides. The subtraction property of inequality says that if I subtract the same number to both sides, the inequality is still true. So 13 minus 14, when you combine those, it's -1. -1 is less than or equal to x. Now, this looks a little bit confusing because when I graph it, I'm used to seeing the variable on the left side. Look at the open end here. The open end, the greater end, is pointing to the variable x. So I'm going to rewrite it as x is greater than or equal to -1. These mean the same thing, but this bottom one is a little bit easier to understand, especially when you graph. So this time, I go to my number line to graph it, and x is going to be greater than or equal to -1. So this time I'm going to use a closed circle since it does equal -1. And because x is greater, I'm going to shade it to the right on my number line. And I show the arrow to show all the possible answers there. So now I would like you to try on your own numbers 4 through 6, solve the inequality, and then graph the solution on a number line. Okay, example 3 is our real life application. A person can be no taller than 6.25 feet to become an astronaut pilot for NASA. Your friend is 5 feet 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. So the first thing I notice is I have 5 feet 9 inches, and then I have 6.25. I need to get these in similar form because right now I have a decimal, and then right now I have feet and inches. 5 feet 9 inches. I know 9 inches out of 1 foot is 9 over 12, which is 0.75. So instead of saying 5 feet 9 inches, I'm going to use 5.75. Okay. So the height of your friend is currently 5.75 feet tall. And they can grow, I'll say h will be the height that they can grow. And they have room to grow as long as they are no taller than 6.25 feet. So that's the maximum height that they can be. They can be equal to this amount, but they cannot be greater than this amount. So they have to be less than or equal to 6.25. Now, in order to find the height, we have to solve. So I will subtract 5.75 to both sides of the inequality to isolate my variable h. This will cancel out, and I get h is less than or equal. When I subtract, I get 0.50, and this is feet. So that means my friend can grow half